Hello all of you. Welcome to JG Chemistry. Guys, this is our second video on CSIR NET June 2021 questions. If you haven't seen that, you can find the link of that video from the description box of this video. In today's video, we are going to discuss again some questions from your CSIR June 2021 NET examination, which held on 16th February 2022. And we will see that there are many questions came from this textbook by Carruthers. So we will relate each question with this textbook, and you can find in CSIR NET many questions coming from this modern methods of organic synthesis by Carruthers. So if your concepts are clear on the topic, you can refer this book for your practice. Definitely it will help you a lot to clear your exam. So now we'll start. So this was one of the question which came recently in your CSIR NET exam, that where you had to find out the PKA order values for the given molecules. So this question you can see, this is the very first topic of the book Carruthers. You can see page number 1 here, where they have mentioned about the PKA and acidity relationship. So basically you can solve this question with respect to the acidity. We know that acidity is inversely proportional to pKa, or you can say pKa is inversely proportional to acidity. So you just have to find out the most acidic proton which will have the least pKa value. So in this third molecule is, because of the steric hindrance, this is the most acidic proton, and so it will have the least pKa value. In the B structure, you can say that this is the less stable carbanion, because you have here electron donating group which will delocalize here with this carbonyl group, and if you abstract the proton from here, the proper delocalization of electron won't be there. So this is the least acidic compared to the 3, therefore it will has the highest pKa value, and based on this concept you can solve this question. This was the next question, where you had to find out the bond dissociation energy for the given molecules. So we know that the triple bond is the most stable as compared to second and double bond and the sigma bond, based on the hybridization sp, sp2 and sp3 hybridization. And you can see here, based on the s character sp hybridized, the concept is given here, and you can apply the same concept here and solve it. So most is stable, the triple bond being sp hybridized, then sp2. Compared to these two protons, both are sp3. This is having the 3-membered ring, so therefore it will have more s character, and so it is, compared to the cyclopentadiene, it is more stable, therefore require high dissociation energy. This was the third question, which was from the organometallic chemistry, where they are asking you organocopper reagent, and this you can see here. This kind of example is given here. You can see where Me2Cu-Li is given and the cyclic molecule. We know that the methylation occurs here, the substituent which is present here, and 1,4 addition takes place. So alpha beta unsaturated, it works here, and opposite direction you can show the stereochemistry. If the Me is down the plane, the product is going to be above the plane, or if it is above the plane, because of the steric crowding. So, and if you see the mirror, like the question was, you have to find out whether the following molecule is chiral, achiral. So if you imagine a plane here in the center, it doesn't have the plane of symmetry, it doesn't have the center of symmetry, so we can say the molecule is chiral. So that was the answer for the given question, and it was given here. You can find out this question in the book. The next question from the CSIR exam was based on again organometallic reagent. This is the Grignard reagent. In the presence of palladium catalyst, organopalladium, this chemistry is involved here. And we know this is given here in the same book. The cyclic first, you have oxidative addition will take place. So basically the reactant is alkene having the electron releasing group here. Then the transmetallation will occur. Then you have reductive elimination. After following these 3 steps, you can design the product and ultimately the X will be replaced with R here, and we have here pH. So you have to just replace the Cl with pH after following these three steps. So basically organochemistry question, and it is again you can find from this book. The next question is also based on, you can see 9BBN, which is a boron, a sterically hindered boron reagent, which is used for the reduction reaction. It reduces the less hindered double bond, and you have again the same organopalladium catalyst. So we have two reactions combined. You can see this example 1.205 is you have 9BBN given here and the palladium catalyst is given. Similar kind of example is there. So basically you can solve this question as well. You can see the addition of sterically hindered boron will take place on this this less hindered double bond, where the boron will add to the less steric carbon, which is the terminal carbon, and hydrogen will come on this center carbon. And similarly, after that you can do this same oxidative addition, transmetallation and reductive elimination, and finally you will have pH here. So the boron will replace with pH. Next question in your CSIR exam was, you can easily see this is the reaction of a very famous name reaction called Diels-Alder reaction, where you have a diene and you have dienophile, which is a heterodienophile in the presence of Lewis acid. We know it is a 4+2 cycloaddition reaction, and you can see the similar kind of example is given here. These two examples you can see, and you can find the how to design such kind of product. So you can see the reaction. This is how the reaction is going to take place. You can see there is a slight change in the orientation of the dienophile because nitrogen is being electronegative, will have here minus charge, and you have positive charge here. And you can see here you have electron donating group. Like that the reaction will take place by endo approach. Okay, so the groups are inside, and 4+2 cycloaddition because of the secondary bond interaction. You can show the stereochemistry. Here this bulky group is you can imagine on your left hand side, and similarly the CO2 ET is on your left hand side. Both are on the same side, so we can show the same stereochemistry. So basically, if your concepts are clear, how to do the Diels-Alder reaction, what is endo approach, what is reduced selectivity, okay, and how to discover the stereochemistry, then you can definitely use these questions, these reactions for your practice, because sometimes direct question comes from this book and you won't have in that case any fear. This is again, you can easily identify, you have here alene and a trans alkene is given under thermal condition. Basically it is again the reaction from pericyclic reaction, 2+2 cycloaddition will be there. And here you can notice, here in this book it is given ketene, while here only difference is instead of ketene you have alene. Again trans alkene is there, and you can find out the major product is trans here. So you have to decide with the stereochemistry, the options will be given to you, and finally you can show the stereochemistry. If you start with trans alkene, then your product is also have the trans alkene, because in Diels-Alder reaction syn addition takes place. So retention of configuration will be there. If you start with cis, the product is going to be cis. If it is trans, it is going to be trans. So 2+2 cycloaddition, and it was a direct question from the textbook. This is again a very famous name reaction called Ene reaction. So you can find this question as well in the same textbook. Here only difference is instead of you have the disubstituted alkene, you have a cyclic alkene here. Same type of reagent is given to you, reactant is given, and reagent is as well given here. Same reagent is given here, right? So basically Ene reaction is this, and you have to follow the mechanism. You have alpha hydrogen present near to the double bond. So this is how the mechanism will take place for Ene. So if you are familiar of Ene reaction, you can design the product, and you can see the question is directly from this book. So basically this question is again, you can see they are asking you the structure of the intermediate generated by CHCl3 plus QH. And we have used this reagent many times for the generation of carbene, right? So you know this reaction, and carbene is again given here. You can find carbenes in any other organic chemistry textbook as well. So basically they are asking you the intermediate carbene where you have 2 electrons, so whether it is going to exist in the singlet state or triplet state. So we know that singlet state with the 2 paired electron is going to be stable because of the lowest energy, it is more stabilized. So answer is singlet. So this was given in the question and it is again given in the textbook. So basically we have seen so far 9 questions coming from the recently held CSIR exam from Carruthers. So you can use this book for your reference. Direct question comes from here, and then you will be having the idea of how they ask the question. You won't get that fear. You can promptly solve all the questions. So all the best. See you in the next video. Bye.